Hi everybody, welcome to our 7.2 lesson. We're looking today at properties of quadratic functions in our notes, and I'm going to ask you to open your yellow data booklet up today and have open your chapter 7 formulas. We're going to refer to those at least once. So if you don't have those, pause this video and go ahead and open those up for yourself. And let's get started. So today, the first property of a quadratic function or property of a parabola that we're going to look at is the vertex of a parabola. Okay, the vertex is the highest or the lowest point on a parabola. Okay, really simply stated. So if we look at these two parabolas that we have here, whenever a parabola opens down, okay, the highest point, in other words, the highest vertical point here is going to be at the top right there. So your vertex, whenever your parabola opens down, okay, there's the vertex of that parabola. Okay, so the vertex, okay, will give a maximum value for y. Okay, so that's the highest point, the highest y coordinate, the point with the highest y coordinate on my parabola. Okay, and it'll end up being here. I can see that the y value of that point is at 8, so that the y coordinate is y is equal to 8 for this parabola. If a parabola opens up, the vertex will be the lowest point on the parabola. There's my vertex. Okay, so looking at this parabola vertically, like going up and down it with my eyes, I see that the very lowest point I have is right there at the bottom. And so that would be, in this case, it's at y is equal to 0. And that's going to be the lowest value for y that I can get, okay, for this parabola. So when it opens up, your vertex, okay, we'll say we'll give a minimum value for y. Okay. One thing that is always true about the vertex is that it lies on the axis of symmetry. So if I were to draw the axis of symmetry into these two parabolas, the axis of symmetry is going to be the line that cuts right through the middle of this parabola. So it's going to divide my parabola into two equal symmetrical parts. And it happens that it will always be coming right through the center, which will always be right through the vertex. And so if I took my ruler here and I tried to estimate this and draw a nice straight line, okay, it looks like that one pretty close to my line's not that straight, but it looks like it goes right through x is equal to -1. Okay, but there's my axis of symmetry. We can also call this the line of symmetry. Okay. Often in math, we refer to it as the axis of symmetry. It just means that if you could flip this parabola around and around the line, x equals -1, it would still look the same. Okay, so we could rotate it around and it's symmetrical. Over here on my other parabola, I see that this time the axis of symmetry runs right through the center, which will be right through this vertex, and it actually looks here like my axis of symmetry is actually the line x equals 0. It runs right along the y-axis. Okay, so it splits it right through at the origin. Okay, remember that the axis of symmetry also has an equation, x is equal to some number. Okay, so the axis of symmetry for my first one looks like it's x is equal to -1. So it's just the place where it goes right through the x-axis. And over here it looks to me like my axis of symmetry is x is equal to 0. That looks like the equation for that axis of symmetry. Okay. When we look at a parabola, there's something special about the vertex. Okay, not only is it the minimum or the maximum point on my parabola, so the lowest or the highest point, it's also the only point that has a unique y coordinate. Or in other words, it's the only point where the value of y, okay, is only being used once. If I were to draw horizontal, okay, straight lines through this parabola, I would see that it intersects the parabola twice, almost everywhere. Okay, so let's write that down. We can draw horizontal lines on the graph of a parabola, and each line will intersect the parabola twice, so at 2 points. Okay, everywhere along that parabola except at the vertex, where a line would only intersect the parabola at 1 point, okay, at that vertex. What I mean by that is if I just chose to draw a horizontal line anywhere here, so maybe it's right through this point, y is equal to 8, it would intersect my parabola twice. Okay, so there are 2 points on that parabola across from each other that have the same y coordinate. I could do it again, let's say right here. Okay, around y equals 5. And again, it intersects my parabola twice, so there's the same value of y for 2 different points. There's only going to be one place, and it looks to me like it's right around 2 here, where if I drew a horizontal line, it would only intersect my parabola once. And so that would be the vertex right there. So what's true about the vertex is that it has, okay, a unique value for y, or a unique y coordinate. Okay, it doesn't share that y coordinate with any other point on the parabola. It's just at the vertex. So any horizontal line will intersect the parabola once only at its vertex. Otherwise, it will always intersect your parabola in 2 points. Okay, let's talk a little bit about the axis of symmetry. And we're going to still talk about the vertex because it's really important here. If I just do a quick sketch of a parabola, let's say that opens up like this. Okay, and I know my vertex here will be the very lowest point on my parabola. And I know that the axis of symmetry is the line that separates this parabola into 2 identical parts. The axis of symmetry always passes through the vertex. And the axis of symmetry has an equation that describes the value of x everywhere along the line. So for example here, if x is equal to 6, okay, so this is my axis of symmetry. X is equal to 6. Okay, that means that it goes through the x-axis, okay, at x equals 6. And that also tells me that if my vertex is sitting on the line of symmetry, then my vertex has the x-coordinate 6. So whatever my vertex is here, okay, it'll be the point 6 and then some number for y, okay, which we will have to figure out. But this is really important. The fact that your vertex sits on the axis of symmetry tells you immediately what the x-coordinate is for your vertex. Okay, then you can actually plug that value of x into your equation. So we could find y. We're going to do that in just a moment. But we could figure out what is this value of y, okay, just by plugging in 6 into my standard form equation for my quadratic, and it will give me a value for y when I simplify and do the math. We'll come to that in just a moment. Okay. Let's talk a little bit about graphing a quadratic function. If I was given this equation, y is equal to x squared plus x minus 2, well, what I could do is just sketch a quick graph by making a table of values, choosing some values for x, solving for y, and then plotting those points on my graph. Once I start to see the shape of the parabola, I can complete it, okay? And then I can see from my graph, my vertex, my axis of symmetry. Okay, so let's go ahead and do that. If we make a table of values, x always comes first in my table of values, and then y. And sometimes when you have a few steps to do here to figure out what y is, it's nice to actually put the equation right into the table as well. Okay, so I'm going to go ahead and do that. I'm going to pick a few values of x, and then I'm going to solve for y. Let's pick a few values in the negative, a few in the positive. So maybe we'll start with -2, okay, all the way up to +2. Okay, so -2, -1, 0. Okay, 1, 2. That's good. That should be enough to give us the shape of our parabola. If you do this and you're not getting the shape of your parabola, you just need to pick a few more points. Okay, so let's plug in x equals -2 into my equation for this parabola. So I'm going to put everywhere I see an x, I'm going to put in the value for x. Okay, so I'm going to have -2 squared plus -2 minus 2. I have to keep that constant negative -2 in my equation. So what do I get here? Well, -2 squared is +4. +4 minus 2 is +2. And 2 minus 2 is 0. So y is 0 when x equals -2. Okay, let's do it again for x is equal to -1. Going to put in a -1 everywhere that I see an x. And I'm going to get -1 squared, which is 1. 1 minus 1 is 0. And 0 minus 2 is -2, -2. All right, let's put in a 0 now for the x. And I get y is equal to 0 squared, which is still 0, plus 0 minus 2. Okay. And before, I'm going to keep going, but something you should notice right here is that we just found two y values that are the same. In other words, right here, okay, these 2 points, even before I graph it, I already know that these 2 points are going to be right across from each other because they have the same y value. So they're both at y equals -2, and they're going to be directly across from each other. Okay, so these points are going to be horizontally across from each other. That also tells me really quickly, if I know that any 2 points with the same y value, right, I know that they're equally distant from the axis of symmetry. So the axis of symmetry lies right in the middle of these two. So it will be halfway between these 2 points. So even without graphing it, from your table of values, if you see a repeat value for y, that tells you that those 2 points are going to be across from each other, and your axis of symmetry will run between them. That also means that your vertex is somewhere in there as well. Okay, let's keep going and finish up our table and graph this. So I'm going to put in x equals 1, and I'm going to square it. Okay, so I get 1 squared, which is 1, plus 1 is 2. 2 minus 2 is 0. Okay, and the very last one I'll do here is, sorry, I should have had an equal sign there. Y is equal to 2 squared now instead of x, plus 2 minus 2. So I have 4 plus 2, which is 6, and 6 minus 2 is 4. So I'm going to go ahead here and I'm going to plug in the values that I have, and let's see what I get for the shape of my parabola. Okay, so we could start at the point -2, 0. Well, that's when y is 0 and x is back 2. Okay, there's my first point there. The next point is going to be the point -1, -2. So I'm going to go back 1 and down 2. Okay. The next point is the point 1, 0. So that's +1 for x, okay, and 0 for y. So it's right at x is equal to 1. And the next point is when x is 2, y is 4. So I'm going to go over 2 and up 4. Okay. And so we can start to see the shape of our parabola right here. If you can't, you can always pick a few more points. You may have decided you want to go back and pick a point for over here, like maybe see where does this parabola, where would I plot a point if x is equal to -3? So you could go back and add another point in here if you wanted to, but we can already start to see the shape of it. This looks like this is a parabola that is opening up. Okay, and so I'm just going to go ahead and fill in what I see here. Okay, it doesn't have to be perfect, but okay, I get the general shape of my parabola just by looking at the way the points are going here. Okay. From my table and my graph, I can see that the axis of symmetry is going to be right in between those 2 points that had the same y coordinate. Okay, so it's going to be running right in between those points. And I can also see that the vertex is going to be a minimum value here. Okay, if I wanted to figure out what those exact values are, I can do that. Let's go ahead and do that now. So finding the axis of symmetry from a graph or from a table of values. Okay, remember that the axis of symmetry is right through your parabola. So any 2 points with the same y coordinate, so in other words, any 2 points that are across from each other, the line of symmetry is halfway in between them. Okay, so if we were to look at our graph or our table and pick 2 points that are across from each other, so that means they have to have the same y coordinate. Okay, let's look. If we look at our table, we already found them. Okay, we said that these points here have the same y coordinate. Okay, and here they are here also on our graph. Okay, they have the exact same y coordinate. Okay. Oh, sorry. Those ones will work too. 0, 0. The points that have the exact same ones are 1, -2. So I just come down here for a second. So 1, sorry, -1, -2. So that's this point here. Apologize. And 0, -2. So that is right here. That's this point right here. So 0, -2. Okay. I think I may have forgotten to plot that point. But anyway, so you have a couple of choices. Any 2 points that have the same y coordinate. So any 2 points that are right across from each other. So we could use these 2 points right here, which I'm going to use. Okay, but you could also use this point here and this point here because they also have the same y coordinate. So that would work as well. Okay. So pick 2 points for yourself. So we're going to use the points -1, 2, and 0, 2. Okay, because I know that the y coordinate is the same there. And the axis of symmetry is going to run right through those 2 points, which means that the equation, okay, x is equal to some number, is simply an average between your 2 x values. So in other words, your axis of symmetry is exactly halfway between x equals 1 and x equals 0. It runs right through there. Okay, so it's going to be an average of those 2 points. So if this is x, the point x equals -1, and there's my x equals 0. Okay, because I know these 2 points, okay, are equally distant from the axis of symmetry, so my axis will have an equation, okay, which is an average of x equals -1 and x is equal to 0. So in your formula sheets in chapter 7, so you've got some chapter 7 formulas in your yellow data booklet, and you have this equation in your booklet. Okay, and it's telling you that the equation for the line of symmetry is an average, okay, of 2 x coordinates that are across from each other. Okay, so you're simply going to, if this is for 2 points that have the same y value, the y coordinate. So you pick 2 points that are across from each other, and you're simply going to average out the two x values. Okay, it's an average of those two. So x is going to be equal to negative 1, okay, plus 0, because those are the two x coordinates for those points. And I'm going to take an average, which means just divide it by 2, because it's halfway in between those two. Okay, so we get negative 1 plus 0. Well, on the top, that gives me negative 1. Okay, divided by 2 is equal to negative 0.5, or negative a half. And you might have even been able just to look at that and do it in your head. You know, halfway between negative 1 and 0 is going to be at negative 0.5. Okay, so my axis of symmetry runs through the x-axis at negative 0.5, and I can then write that out right here. Okay, so x is equal to negative 0.5 is the equation for the line of symmetry, or I'm going to call it the axis of symmetry. Great. So we could go back to our graph now and just put our line of symmetry right in, and now we can state the line of symmetry is the line x equals negative 0.5, or negative a half. Okay, so let's come back here, and that looks about right, doesn't it? Because if I were to just eyeball this, it looks like the line of symmetry runs right in between. Sorry, that's my pen is a little bit off here for calibration, but it looks like it's running right in between. Let me do that a little bit better. Right in between 0 and negative 1. Okay, so I'll try to come back down here and do my best. I think haven't done a great job here with my sketching. Okay, but my line of symmetry is right here at x is equal to negative 1/2. Okay. Okay, there's my axis of symmetry. Okay, if we wanted to know where the vertex of this parabola is, it's going to be really easy to identify because I know the vertex lies right on the line of symmetry. Okay, so I can actually figure out now what is the y value. I see it's going to be negative something. It's below the x-axis. But to figure out what its exact value is, I know that the x-coordinate for the vertex is negative 0.5 because that vertex sits right on the line of symmetry. So to find the vertex, once we know the axis of symmetry, okay, so in this particular example, it's x is equal to negative 0.5. That's the x-coordinate for that vertex. So I'm going to substitute the value of x into the equation for the quadratic function. So I can have a look at my equation that I graphed originally, okay, which was y is equal to x squared plus x minus 2. So this is the equation for my whole parabola. And what I know is that anytime I put in a value for x, it tells me what the y value is at that point. Okay, and so I know that my vertex lies, I know that it's on the line x is equal to negative 0.5. So I know that that's what its x value is. Okay, that tells me that's the x coordinate, okay, of my vertex. So I'm going to just go ahead and plug that negative 0.5 in to my equation everywhere I see an x, and I'm going to solve to figure out what the y value is. So let's do that. We get negative 0.5, okay, squared is going to give me positive, negative times a negative is a positive, 0.25. Okay, and then I've got plus, or minus, I should say, minus 0.5 minus 2. So if I do this in a couple of steps, okay, what I'll get is this is going to be 0.25. Okay, negative 0.5 and negative 2, I could put those together. That's going to give me a bigger negative. That's negative 2.5. And so 0.25 subtract negative 2.5, y is equal to negative 2. 0.25. Okay, so that is the coordinate for my vertex. So my vertex has the y coordinate negative 2.25. So the vertex is the point. Okay, x is negative 0.5, y is negative 2.25. And you know what? That might have been a little bit difficult for me to see from my graph. I might have been able to estimate it, but now I can say for sure. I might have looked at my graph and said, oh, it looks like it's around negative 2 for the y value, but now I can be certain. Okay, so if I go back to my graph, I could put the value of the vertex in now. It's at negative 0.5, negative 2.25. Okay, so there's my vertex right here, the lowest value. Okay, and that vertex has the coordinates negative 0.5 for x, negative 2.25 or 2.25, okay, for y. Okay, stating the domain and the range. Remember that when we look at a quadratic function, it's a continuous function. So what I know is true is that x and y are all real numbers. Okay, so the domain is really simple to state. The domain is your x values. So from where to where, okay? What's the lowest value of x? What's the highest value of x? And for this parabola that we looked at here, okay, I can see that x just continues on in the negative direction and also in the positive direction. So there's no restrictions on my domain. X, if I use set notation, I can say x is simply all real numbers. Okay, x is such that x is a member of the real numbers. So there's no restrictions on x. That's always true for quadratic function. The range is the range of your y values. So are there any restrictions on your y values? And you will always have one restriction, which is that you will always have a maximum or a minimum value of y. All right, so your vertex will always be the highest or the lowest value that you can possibly have for y. And so if we look at this graph that we did here, the vertex was the lowest point on the parabola. Okay, so it's the minimum value of y. So another way to say that is that y can be equal to negative 2.25 or greater than that. Okay, that's the lowest point, so y is going to be anything above that point. So here we'll say y, okay, is greater than or equal to the lowest point, which is negative 2.25. If this parabola opened down, we would say y is less than the highest point. Okay, less than or equal to the highest point. But in this case, it opens up. Okay, and we'll add on there that y is a member of the real numbers because this is continuous. It's not discrete. Okay. Okay, finally, the last thing that we want to cover here and have a look at is function notation. And by function notation, this is just another way to write an equation for a quadratic. And we've actually seen it before if you've taken Math 10. Function notation is just another way to write y equals. Okay, so instead of saying y is equal to well, let me use the example here. Y is equal to x squared plus x minus 7. We can also write f of x equals x squared plus x minus 7. And this is simply called function notation. And what it means is that quite literally y is a function or depends on x. Okay, so instead of saying y equals, we're just saying a function of x, okay, or y depends on x such that x squared plus x minus 7 will give me a value for my y. And the reason why we do it this way, because it's somewhat useful to us, if we have different values of x that we're plugging into our equation, it's really easy to show that using function notation. So let me give you an example. Okay, so for different values of x, so if we were just picking some values of x and substituting them in, okay, we can write, instead of y is equal to and then just putting in a value of x, we'll say f of 1, I'm going to use 1 as an example. So this is just when x equals 1. I want to know what y is equal to. Okay, so function notation just lets us show very quickly what value for x I'm using. Okay, so f of 1 is equal to 1 squared plus 1 minus 7. Okay, so what we'll get here if I work this out, f of 1 is equal to, well, 1 squared is 1, plus 1 is 2, 2 minus 7 is negative 5. So in other words, y is equal to negative 5 when x is equal to 1. Okay, so this is the same as y equals negative 5. F of 1 is just like y. Okay, the difference is just as useful for us. Okay, another example here, f of 0. Okay, if you see f of 0, that means y when x equals 0. Okay, and you've simply put in a 0 everywhere in your formula that you have an x. And so here we would get f of 0 is equal to negative 7. Okay, there's just the y-intercept, negative 7. That's the point where it crosses the y-axis, okay, when x equals 0. And this is just the same as y equals negative 7, okay, when x is equal to 0. So function notation is just another way to write an equation. We use it a lot in math, so you want to be familiar with both of them. And I'll just quickly show you on your formula sheet, I show you that. Okay, so to keep track of some of these formulas here, if you go to your formula sheet for a moment, just have a look at the chapter 7 formulas. One of the first ones that we have there, okay, is standard form for quadratic. And you've got, this is standard form. This is the one that we started off looking at in chapter 7, y equals ax squared plus bx plus c, where a has to be a value either greater or above 0. It can't be 0 because then we wouldn't have an x squared. Okay, but this is standard form, or this is just function notation. So it means the same thing, and I put it there to help remind you. Basically, f of x is y. Okay, they're the same thing. Okay, the other equation while we're looking at your formulas, if you have a look down below, okay, there is that equation for the axis of symmetry. It looks a little bit different here. It's r plus s over 2. Okay, this can also be written as, and we'll talk about what r and s are a little bit later, but essentially r and s are just two x values for 2 points that are across from each other. Okay, so this is also the same as x1 plus x2 over 2. So x, your axis of symmetry, x equals some number. Well, that number is going to be an average between 2 points, okay, that are across from each other. And you're looking at the x coordinates of those 2 points. Okay. Let's come back to our notes and just finish up here. Okay. A couple of examples, different ways of asking you questions. Example 2, state the coordinates of the y-intercept and 2 other ordered pairs. Ordered pairs are simply points. I want to introduce you to some different language here. Ordered pairs just means a pair of x and y coordinates, okay? So just another point for this function. F of x, which is, by the way, the same as y, equals 2x squared plus 3x plus 2, okay? And I want to know what is the y-intercept and 2 other points. So first off, let's find the y-intercept. Now, you don't even have to plug anything into this equation. The y-intercept is always your c value. So when you look at a equation in standard form, it's ax squared plus bx plus c, right? So there is your y-intercept right there. Okay, it's at positive 2. So c is equal to positive 2. And I don't even need that positive sign in there. I'll just say 2. So there is my y-intercept. If I wanted to write that as a point, okay, I can write that. That's the point. 0 for x, because remember, it's right on the y-axis. 2 for y. Okay, there's my point. Another way that you could have done that is you know that your y-axis, okay, everywhere on your y-axis, the x value is 0, right? Everywhere along your y-axis. So if you wanted to know where a parabola crossed the y-axis, you can simply put in x is equal to 0, okay, into your equation. So substitute in a 0 for x, because you know that everywhere along the y-axis x equals 0. Okay, so we could have also done this. Okay, and we would have gotten, well, that cancels, that's 0, so all we get is 2. Okay, either way works. The second thing I want to do is just figure out 2 other pairs. I don't have to graph this to figure out what 2 other points are. Just simply pick a value for x and plug it in, and we'll figure out what the y-coordinate is. You can pick any value you want. Okay, remember that the domain for a parabola is just x is equal to all real numbers. There's no minimum or maximum x value that you can pick. You can pick anything you want. So maybe we'll pick, okay, so we're going to simply just choose, okay, 2 values of x, and that's going to give us 2 points. So point 1, maybe we'll pick x is equal to 1. So we can use function notation. F of 1 is equal to, well, the formula, but everywhere I have an x, I'm going to put a 1. Okay, let's see what I get for that. Well, 2 times 1 squared is 1. 2 times 1 is 2. Okay, 2 plus 3 is 5, and 5 plus 2 is 7. So in other words, y is equal to 7 when x is equal to 1. So 1 point, okay, that I have is the point 1 for x, 7 for y. Okay, let's do another point. Let's call this point 2. And let's choose a different value for x, anything you want. It could be negative 100, it could be 0.5, it could be something really simple, just like negative 1. Okay, maybe I don't feel like doing a lot of math here, so I choose a simple value for x. And again, I can use function notation. Okay, when x is equal to negative 1, let's figure out what y is. So I'll put in a negative 1 everywhere that I have an x in my formula. And what I get here is that when x equals negative 1, we have negative 1 squared is 1. Okay, so 1 times 2 is 2. Okay, 3 times negative 1 is negative 3. And I have that plus 2. So what I get here is that f of negative 1 is equal to, well, that's going to give me 2. Subtract 3 is negative 1. Negative 1 plus 2 is just positive 1. Okay, so there's my value of y. Y is equal to 1. So this is going to be the point. Negative 1, 1. So there's 2 other ordered pairs on this parabola. 0.17 and the point negative 1, 1. Okay, finally, this is a little bit of a trickier question because I want to give you at least one sort of full question because you are going to be asked this in your homework. It says, for the function below, we have a parabola, it's already been graphed. Identify the axis of symmetry, determine the coordinates of the vertex, so in other words, state the vertex, and state the domain and the range. Okay, let's go ahead and start this off. Okay, so I'm looking for axis of symmetry. Okay, I'm also looking for the vertex. and then the domain and the range. Okay, will be the third thing that I'm going to do here. So let's start off with the axis of symmetry. If it's very easy to see the axis of symmetry from your parabola, then that's fine. But remember that if you're just eyeballing it, you're really just estimating it. It is better to calculate the axis of symmetry, and then you know you're exact. So what we're going to do if we want to calculate the axis of symmetry is just find 2 points that have very clear coordinates, okay, that are directly across from each other. Okay, so we're going to look for 2 points with the same y coordinate, and we're going to take the average of their x values. So we're going to use this formula. X is just the average, okay, of 2 points that are directly across from each other. So go ahead and look at your parabola, and you have a couple of different points you could pick. A and C have very clear coordinates because they're right on the grid lines. So those would be 2 great points to use. You could also pick this point B and the point that's directly across from it. I can see that both those points have the exact same y coordinate. Y is equal to 1. Okay, or if I pick the points A and C, I can see that they're both right at y is equal to 2. So either of those points would be acceptable. Okay, you have to pick 2 points that are on the exact same horizontal line. So they have to be right directly across from each other. Let's go ahead and pick these points. So let's pick the point, this is the point 1, 2. Okay, and this point over here is the point 5 for x and 2 for y. Okay, so I see that they're at the same place on the y-axis, and so I'm going to take the average, okay, of the x values. So I know the axis of symmetry runs right in between 1 and 5. Okay, so I'm going to find the average. So it's going to be 1 plus 5, and the average is to add them together and divide them by 2 because it's halfway in between them. So that's going to give me 6 over 2, which is equal to 3. Okay, so the axis of symmetry, okay, the equation is x is equal to 3. So the axis of symmetry runs right through the point x equals 3. And that looks like exactly what we would have estimated anyways. Okay, so let's write that down. So the axis is x is equal to 3. Okay, there we go. Second thing that we have to find here is the vertex. Well, what you already know about the vertex is that it sits right on the axis of symmetry. Okay, so there's the vertex. It's the lowest point on this parabola. And I already know that the vertex is on the x equals 3 line. So that tells me that the coordinate for x is 3. I just need to figure out what is the coordinate for y. Okay, so that's what I'm going to do. I'm going to plug in x equals 3, okay, into my equation. Now, if I had an equation, which I don't here, I would normally plug that in. Okay, so for this one, I know that this lies on the axis of symmetry. Okay, I would plug in x equals 3 into the quadratic equation, so the equation of the parabola, okay, to solve for y, okay. And that would give me the y coordinate, but in this case I don't have the equation, so here I have to estimate. Okay, so let's go ahead and estimate it. Looking at it, if I have a look, it looks to me like it is, if I come over here to the y-axis, it's not quite at 1, but it's above 0. It looks to me like if this is the halfway point, 0.5, Okay, it looks like it's just above the halfway point. So it's a little bit more than halfway between 0 and 1. So we might estimate that that's at about 3/4 or 0.75. Okay, so that would be a safe estimate. Again, if you had the equation, you would plug it in. Okay, and you figure out exactly what it is. So here's my estimate. My estimate is that the vertex is at, okay, 3 and 0.75. Okay, finally, the last thing I'm going to do here is state the domain and range. I'm going to do that up here. Domain's really easy to state for this. This parabola runs in both the x, negative and positive direction for x. So the domain is simply that x is all real numbers. Okay, and the range for this, y, is such that, well, y is also all real numbers, but there is a minimum. Okay, the minimum is at the vertex. So y, the minimum value for y is at 0.75. That's what I estimated. So I'm going to say that y is either equal to 0.75 or it's greater than that. So y is greater than or equal to 0.75, which is the minimum, and y is a member of the real numbers. Okay, great. This is the type of problem that you're going to see in your homework. So I'd like you to go ahead and try some now. We're looking on our textbook, page 368, numbers 1 to 8. And good luck. Thanks for joining me today. We'll see you next class.